Hi everyone, this video is going to go over properties of rectangles. So a rectangle is a type of quadrilateral, it's a type of trapezoid, particularly an isosceles trapezoid. I know that definition is a little strange. Sometimes your teacher might go through it a little bit differently, but here in New York, we follow that definition. And then a rectangle is a type of parallelogram as well. That means it inherits all of those properties. So for instance, it takes the properties of a quadrilateral, like it has four sides. It takes the properties of a trapezoid, like same side interior angles are supplementary. It takes the properties of a parallelogram, opposite sides are congruent and parallel. But there are two new properties for rectangles that are unique to rectangles. That's that the consecutive sides are perpendicular. That means they form right angles. And also that the diagonals are congruent. So we're going to be working a lot with those two facts throughout this video. All right. Number one, true or false, the diagonals of a rectangle are congruent. That is true. We just read that in our facts. Number two, the diagonals of a rectangle are perpendicular. This is false. If you had trouble with this one and you got confused because the sides are perpendicular, what I would suggest is look at a picture of a rectangle. You could even draw one yourself. Draw in the diagonals. Do these look like in here 90-degree angles? That would mean they're perpendicular. Okay, if they're perpendicular, they form right angles. Those don't look like right angles. They look like acute or obtuse angles. So that's how I know, okay, the diagonals are not perpendicular here. All right, number three, find all the missing angles in the rectangle below. Okay, well, I know this angle, bottom left, is 90. To figure out the other angles, there's different things that you could do. For instance, one I see is that up top, those two angles have to add up to 90. So if I take 90, subtract 57, I get 33. I know basically those numbers are going to appear down here. And the way we could do that is through alternate interior angles. Those are often identified in a Z shape, just like I'm highlighting here. They're the angles in the corner of the Z, and therefore they're congruent to each other. All right, number four. In rectangle ABCD, if AC is 18, find the length of BE. Well, diagonals of a parallelogram bisect each other. Since a rectangle is a type of parallelogram, that is also going to hold true. So if AC is 18, I know that it's split 9 and 9. When I look at diagonal BD, it must also be 18 because the diagonals are congruent. And since they bisect each other, it's also going to split 9 and 9. So BE is equal to 9 here. Number five, in rectangle DEFG, the measure of angle DHG is 108. Find the measure of angle HDG. So we're looking for this angle here. So one suggestion for this, I'm just going to zoom in on this picture a bit, is when we were talking about the diagonals being congruent and the diagonals bisecting each other, what that really means is each of these four like small pieces that form the two diagonals are going to be congruent. Here's why that's important, because basically what you are then creating is an isosceles triangle. If I just draw that top piece here, that top triangle, this is 108, and I know these two sides are congruent. Well, in an isosceles triangle, the base angles, that's these two, have to be congruent. So I'm going to subtract 108 from 180, divide by 2, and each of these comes out to be 36. So that is what we are looking for in our picture here. And we have our answer. Okay, so again, I'm using a couple facts there that in an isosceles triangle, the opposite side, the angles that are opposite the congruent sides are also congruent, and that a triangle has an interior angle sum of 180 degrees. Okay, number six. In rectangle ABCD, AD is 5. I'm going to label as I read here. And DC is 12. Find the length of AC. So I'm basically looking for the length of the diagonal. Now don't forget, we know angle D is 90 degrees because this is a rectangle. So what this really means is we're really using a fact about right triangles here, but we can use Pythagorean theorem to find our hypotenuse, which is the diagonal here. You might also know that this is a Pythagorean triple, and that might save you a little work. But I'm going to pretend that I don't know that here, and I'm going to actually just solve for the length of the diagonal, or C. And when I do that, I get that C is equal to 13. Number 7, rectangle PQRS is shown below. If PR is 16x plus 10, okay, so that's this whole big diagonal from P to R, and ST is equal to 12x minus 7, find SQ. All right, so here's how I'm going to label this. I'm going to actually start with ST being 12x minus 7. I know that the diagonals bisect each other, so this is 12x minus 7 as well. For the length of PR, I'm going to draw kind of like a big bracket marking that off, and that was 16x plus 10. So remember, the diagonals are congruent, so 16x plus 10 must be equal to 12x minus 7 plus 12x minus 7. So let's solve this algebraically, starting by combining like terms over here. And then let's start bringing the variables to one side and the constants to the other. So I have 24 is equal to 8x. When I divide both sides by 8, x is 3. And we want to find the length of SQ. Okay, so SQ was basically, if you look at your picture, or look at mine, it was basically equal to 12x minus 7 plus 12x minus 7, which we combined before to be 24x minus 14. And now we know that x is 3. So plug 3 in. So 24 times 3 minus 14, and we get that SQ is 58. Okay, over on number 8, given rectangle DEFG, measure of angle GDF is 4x minus 2. And the measure of angle EFD is 3x plus 7. And we're looking for the measure of angle EDF, which is this angle over here. Okay, well, first off, these two angles that we were given expressions for, I notice are alternate interior angles. They are in that Z shape. That's like the shortcut way to finding alternate interior angles. And that means that they are congruent. So I know 4x minus 2 has to be equal to 3x plus 7. If I move the variables over, subtract 3x on both sides, add the 2 over, I get that x is 9. All right, so let's plug 9 in to see what we get there. So for the angle that we labeled 4x minus 2, 4 times 9 minus 2 gives me that this angle over here, I'm going to erase the 4x minus 2 for a second, is 34 degrees. Now remember, the angles of a rectangle are 90 degrees. So now I know that 90, or our missing angle, and 34 have to add up to 90. And I get 56 degrees as our answer for the measure of angle EDF. All right, our last question is a coordinate proof. I'm going to just move the calculator out of the way for this one. It gives us the 4 points, and we are going to prove it's a rectangle. There are different ways to do this. I'm just going to go through one possible solution in this video, though. First thing I'm going to do is I'm going to plot all of my points and making sure I label the vertices. So when I plot -1, 2, I'm going to put M next to it, and I'm going to continue to do that for each of the points in this problem. Okay, once I have my points plotted, I am going to just make nice straight lines connecting them. If you're doing this on paper, you would use a straight edge. And here's a rectangle MATH. Now we have to prove this is a rectangle. We have to think about ways that we could use slope or distance formula in order to show that this is a rectangle. I like to do all of my proofs using the distance formula. So the first thing I want to show is that opposite sides, so this is like my goal, my little notes here, that I want to show that opposite sides are congruent. But I have to step back and think to myself, is that going to force this shape to be a rectangle? And the answer to that would be no, because that could just be a parallelogram. If we think about a property that it is unique to a rectangle, it's that the diagonals are congruent. It's the combination of both of these properties that makes a quadrilateral a rectangle. So I'm going to show both of these things, that opposite sides are congruent and that the diagonals are congruent. Okay, and again, there's different ways to go about coordinate proofs. This is the way that I'm going to cover in this video. So I'm going to find the length of all four sides. Okay, so it could be a little tedious at times, but it does get repetitive. And I'm also going to find the length of the two diagonals, so MT and HA. Now, I know that MA, for instance, this first calculation that I'm going to find should be congruent to TH because I can see in the picture that those are opposite one another and therefore should be congruent. That's why I like to have the picture plotted, just so I can kind of verify what should kind of match or be equal here. All right, so utilizing the distance formula for MA, when I subtract the x's, I'm going to get -1 squared. Subtract the y's, I get -3 squared, and that's going to come out to be radical 10. I'm not going to find the decimal version. I'm just going to leave it exact as radical 10. And then I'm going to just repeat this process for all of them. So for AT, when I subtract the x's, I get -6. Subtract the y's, I get 2. That comes out to be radical 40. All right, now we said before MA and TH should come out to be the same, so let's see if we're doing this right so far. When I subtract the x's, I get 1. When I subtract the y's, I get 3. And sure enough, that comes out to be radical 10. Now AT and HM should come out to be congruent as well. So if I look at HM, when I subtract the x's, I get 6. When I subtract the y's, I get -2. And if you're getting -6 or +2, that's fine. We should get the same answer of radical 40 in the end. It just means we're subtracting in a different order. All right, now we need the diagonals to be congruent as well. So let's make sure those diagonals are congruent to one another. When I subtract the x's, I get -7. When I subtract the y's, I get -1. That gives me radical 50. To get these numbers, by the way, I am just doing the math, not including the radical. I'm doing everything inside, -7 squared plus -1 squared. All right, and for HA, our last one, finally, I know it's a lot of distance formula here. When I subtract the x's, I'm going to get 5. And when I subtract the y's, I also get 5 or -5, depending which way you're looking at this. And that will give me radical 50. So everything that we wanted to happen happened. We showed the opposite sides are congruent. We showed the diagonals are congruent. We just need to write an explanation, kind of like wrapping it up, conclusion. So I'm going to say quadrilateral MATH is a rectangle. Because opposite sides are congruent. And the diagonals are congruent. And that would conclude our coordinate proof, and we have successfully shown that MATH is in fact a rectangle.